Good morning, everyone, and welcome to this Lab talk of the food series. It seems that the subject is of great interest because, well, it was expected since this is one of the ISOs that are pillars in the world of microbiology, more of that of quality control. So I appreciate your interest and your assistance, of course. My name is Aletia Cruz. And as some of you may already know from previous editions, I am a microbiology product manager at Lab. So without further ado, let's start with the presentation since this ISO covers quite a few interest topics. So the presentation that we have divided into 5 parts, we will first talk in a general way about the ISO. What is this ISO, to whom it applies, what is quality assurance management, and important parts of it. Then we will continue with the quality control and performance test of the culture media, the controls that exist, requirements, the microorganisms used in this control, and we will also quickly touch on the subject of documentation for a correct traceability of these tests. And in order to fully then enter the test methods that are carried out, the criteria and the method according to the type of medium, we will quickly see the 2 amendments that have been made to the ISO since its last version update in 2014. And finally, the part that I think is one of the most interesting because it will allow us to put all of the above into practice, how we apply this ISO 11133 at Lab. We have, as you can see, we have a lot to go through. So let's start with the first part, the ISO of quality management. In microbiology, if we talk about traditional techniques, we know very well that culture media are the standard and have been for decades. However, media is also used in many alternative techniques, either as pre-enrichment or enrichment step or for confirmation of a result. That is why currently a large majority of microbiology tests and procedures depend on the quality of culture media, that is, on their ability to provide reliable results that are consistent and reproducible in any laboratory and environment. For this, a standardized method such as ISO 11133 is needed since it accurately describes all the elements necessary for quality control of culture media used for food, feed, and water analysis. This ISO includes the preparation, production, storage, and performance testing of culture media. So one of the requirements for any reliable microbiological analysis is that the media meet the established performance criteria. And for this, certain tests must be carried out that demonstrate these criteria, and that can be used to assess the productivity, selectivity, and specificity properties of media. And those are the acceptability of each batch of medium, that the medium is fit for purpose, and that the medium can produce consistent results. These criteria that are one of the pillars in the internal quality control procedures. So another pillar would be the adequate documentation that will allow the supervision of the media and would aid the obtaining of reliable and precise data. Now, we already know that ISO 11133 will be used as a standard for quality control of culture media, but as we have mentioned, this regulation applies to media used for food and feed analysis, including samples from production environments, and also water, any type of water, whether for production or for consumption. But who is responsible for carrying out this verification of media performance? In this case, the ISO applies both to end users of ready-to-use media and to manufacturers of such media, that is, commercial entities that manufacture and or distribute dehydrated media or semi-finished reconstituted media or ready-to-use media, microbiology laboratories that prepare culture media for their own use, and non-commercial entities that provide media to third parties. Regarding quality assurance, ISO 11133 indicates several key points for good management. They include several points, some of which I will mention in more depth than others, since they are the ones that we usually find the users may have more doubts about. First, we have the documentation, which is essential. In this case, the manufacturer must have at the complete disposal of the user all the information of the medium, such as name and code or reference, formulation, including all that of the supplements, if it's a media supplemented, of course, use, safety data, batch number, final pH of the complete medium, the storage conditions, expiration date, and the control with the microorganisms used, and the performance results obtained, of course. So basically, we are talking about the information that can be found in three important documents: the technical data sheet, or TDS, the certificate of analysis, or COA, and the material safety data sheet, or MSDS. With this documentation, the user must verify the information indicating in it and whether it corresponds to the product to be used, and with it accept or not the delivery of said products. The next point would be the conservation of culture media, and for this, instructions indicated by the manufacturer must be followed. Then we have media preparation and storage and shelf life, which we will look at in more detail. For the incubation of solid media, the ISO mentions the loss of water during incubation, which can ultimately affect the growth of microorganisms, and it recommends sacking the plates to avoid this loss or increase the humidity of the air by placing a container with water in the incubator. And finally, for the disposal of contaminated and unused media, local or national regulations must be followed. So on the first point that I have mentioned, I would like to emphasize that all of this documentation, the technical data sheets, certificates of analysis, and material safety data sheets can be obtained from our website, condelab.com. The technical sheet is found always at the bottom of each product, while the certificates and security sheets in the menu at the top, you have to go to documents, and then you get the MSDS and the certificates of analysis from here. So now, for media preparation, we can talk about two parts: the preparation in the laboratory and the preparation for the use of the media. So for the first preparation at the laboratory, we know that proper preparation is essential to ensure the rest of the media quality assurance procedures. So good laboratory practices and manufacturers' instructions must be met, not only in terms of preparation, but also in relation to the handling of components that are hazardous materials, such as biosalts, for example. In addition to this, the quality of each component of the medium is important, especially as there are certain ingredients whose concentration can be altered to achieve stable and consistent performance of the medium. Usually, these types of ingredients are peptones and extracts, which inherently have a variable nutritional properties, agars due to their variability in gelling properties, ingredients with selective functions such as, again, biosalt, indicator dyes, and antibiotics due to their interaction with other ingredients. That is why in some technical data sheets below the formulation, sometimes there is a legend included in certain media saying that the formula can be adjusted to adapt to the performance criteria. Another fundamental ingredient is, of course, water, for which only purified water should be used, that is distilled, demineralized, deionized water. Microbial contaminations should not exceed 1,000 CFU per milliliter, but it is preferable that is less than 100 CFU per milliliter. It is regularly checked in accordance with ISO 6222. Then we have points such as a careful weighting, the unnecessary amount of medium, recommendations for a correct the solution. If heat is used, avoid overheating, very important. pH measurement after sterilization and once the medium is complete and cooled to 25 degrees Celsius, correct dispensing of the medium. And then regarding sterilization, the manufacturer's recommendation or the specific standard of the medium must be followed, whether it is by autoclave or filtration. And lastly, the preparation of the supplements. So try to use them the same day of work, although it is possible for some to freeze them in aliquots, but you should monitor and establish their potential loss of activity, obviously due to its freezing. And regarding the preparation for its use, it refers to the fusion of the media, where it is again very important to avoid overheating. And once the medium has cooled to less than 50 degrees Celsius, the necessary supplements can be added. The ISO also mentions that for 90 milliliter plates, Petri plates, a volume of medium between 18 and 20 of medium per plate is necessary. And finally, for inoculation, the plates must be dried before use, but of course, taking care of the degree of humidity, since, as I have mentioned earlier, this can affect the optimal growth of microorganisms. Now, when it comes to media storage, it is very important to be clear that there is no exact shelf life. In this case, the user must evaluate the useful life of each medium in his laboratory, because although it is true that the specific ISOs may stipulate conditions and shelf life times, this must be verified in the laboratory, as well as specifying the frequency of verification. For this evaluation, the laboratory must check color changes, any signs of evaporation or dehydration of the medium, also changes in pH, unacceptable values of productivity, selectivity, or specificity. Thus, the expiration date will be based on the storage time in which all performance characteristics remain within acceptable values. And in any case, the media must be stored in conditions where they are protected from light and their desiccation is avoided. That said, there are recommended media storage conditions as well as shelf life. And in any case, the media that are not used immediately under refrigeration conditions, it is recommended that the plates be kept for a maximum of 4 weeks, and the sealed tubes and bottles up to 6 months, unless specific regulations or the results of the laboratory evaluations indicate otherwise, and that this shelf life can be prolonged. In the special cases of supplemented media, it would be ideal to use them on the same day of preparation, unless, again, the specific standard or the results of the laboratory evaluation indicate otherwise. And it is also recommended small batch preparation of solid media to avoid repeated media melting, and any unused medium shall not be re-solidified and reused. We have finished the first part of our webinar. In the second part, we will look at the requirements for culture media, including test microorganisms for performance testing. We will begin by reviewing a little of what we've seen previously, that the quality of the media depends on the quality of the raw materials, as well as on a correct formulation. That does not always mean following the relations recipe, if you will, to the T, but sometimes it is necessary to optimize said formulation. The quality of the procedures for preparing the medium and its preparation for its use and the correct storage and conservation conditions. That said, the quality control of each medium must be adapted to the use that each one has, that is a quantitative or a qualitative use. Beginning with the physical and chemical quality control, which is basically to visually assess that the physicochemical characteristics corresponding to each medium are present and ensure that they comply with the filling volume, the appearance in terms of color and homogeneity, the consistency of the gel, and the content of water. In addition, its pH is also determined. And regarding microbiological quality control, we have microbiological performance tests. This should be done on a representative sample of a batch of end product. In this case, we have two important points. The first is the reference medium. This is a generally non-selective medium, which is used for comparative evaluation of performance independent of the medium tested, meaning it is basically a control for the assay. And due to the importance of the reference medium, it must be of a high and consistent quality, and it must be a quantitative medium that contains a defined number of organisms. That is, it has a defined production process, meaning the same manufacturer is used to supply the medium or the ingredients are from the same supplier. And you should also be able to use a larger range of organisms from tests than the minimum. ISO 11133 also includes the acceptance criteria, control methods, and test organisms for the reference medium, which is commonly TSA, although any other reference mediums can be used as long as they meet these criteria. On the other hand, we have microbial contamination. In this case, the sterility of a representative sample of the batch of culture medium should be examined. If it is a small batch, at least one plate or tube must be incubated, and for large batches, ISO 2859 can be consulted to establish the number of plates or tubes required. We continue with the requirements for tests. In general, these tests consist of inoculating the culture medium with a volume of a working culture of each of the test microorganisms following the indicated inoculation technique. And again, the type of test will depend on the use of the medium. For this part, we have ready-to-use media and media prepared from dehydrated formulations. For ready-to-use media, it is very easy if it comes from an ISO 9001 compliant manufacturer, because by maintaining a quality program in place, they can issue a quality certificate for each batch of media they supply, which is the case for CondaLab, and that is why the user, our clients, do not need to carry out an exhaustive analysis of the media they consume. What they must do is to ensure that the recommended storage conditions are maintained. And also, the user needs to carry out periodic checks to demonstrate that the quality of the media is maintained after its transport, storage, and handling by the own user. For example, after the melting of a solid medium. So the user will also need to indicate the frequency. In the case of media that are supplemented and have been tested by the manufacturer, it is recommended that the user carries out a qualitative test. On the other hand, in a case of an incomplete media to which the user adds the supplement, their production records must be checked, or a qualitative test must be carried out to ensure that the supplementation of the medium and its performance is correct. We continue with the media prepared from dehydrated media. In this case, the user must carry out tests depending on the use of the medium. If they are counting media, it will be a quantitative test, and for the rest, a qualitative test may be sufficient. However, the quantitative assay will offer greater quality assurance. In media that do not indicate exactly which strains to use, if they are non-selective media with a reduced number of strains, the control can be carried out. But for selective media, strains that demonstrate the function of the indicator and selectivity should be used. Now, a batch of culture media is considered to perform satisfactorily if all test microorganisms perform within the stated specifications. And it is also accepted if both the general, that is the physicochemical, and the microbiological criteria are met. If not, ISO 11133 Annex H can be consulted for possible reasons for common media problems. For example, here we have two situations that users commonly encounter. The first is when the agar medium does not solidify, in which case the problem usually comes from overheating of the medium. However, there are other reasons such as low pH, if it's prepared from individual ingredients that the agar has not fully dissolved, or the weight is not correct, or also that the ingredients have not been mixed properly. Another case that the users have told us about is the formation of precipitates. Again, the most common cause, and I keep repeating myself, is overheating of the medium. It is quite common. And that is that many media are sensitive, even if it seems otherwise. Even the raw materials are very sensitive. So, but other causes that other than overheating can be the use of low quality water, that the dehydrated medium is of low quality, meaning the components are low quality. Also, it can be that the pH control has not been done correctly, and well, mostly poor quality ingredients. A fundamental part of the performance test, of course, are the microorganisms used. These must have a stable characteristic representative of their species and must also have demonstrated reliability in when demonstrating the performance of a given medium. Both strains from reference culture collections and well-characterized laboratory isolates can be included, and the microorganisms could be robust, positive strains with typical characteristics of the target microorganism, weak positive strains, negative strains that do not show the expected characteristics of the target microorganisms, and completely or partially inhibited strains. So in this sense, the purpose of the different performance criteria and the application of the method determine the selection of the control strains. That is, the strains under study are for productivity tests, while the strains not under study are for the selectivity and specificity tests. The control strains to be used are found in annexes E, F, and K. In these annexes, this last one, which was a result of the new modification in 2020, in these annexes, the appropriate microorganisms are indicated for the performance test of media used for the analysis of food, feed, water, as well as for media and confirmation reagents. And for such assays, the volume of the inocula is critical. For this, ISO 11133 indicates extensive procedures for the preparation of a standardized inocula. This includes guidelines for the preparation of stock cultures, working cultures, test suspensions, and inoculum volumes in general. However, some microorganisms may require special preparation conditions. Regarding the amount of inoculum, this is divided by the type of test to be carried out. For a productivity test, we would have, on one hand, quantitative test, which for the ISO recommends using an amount close to 100 CFU to achieve sufficient precision. This is a range of 80 to 120 CFU per plate with a minimum of 50 CFU per plate. And for quantitative assays of liquid diluents and transport media, the inoculum would be 10 to the third power to 10 to the fourth power CFU. For a qualitative test of the volume should contain, again, at least 10 to the third power CFU for qualitative assays of plate media, less or equal to 100 CFU for enrichment and pre-enrichment media productivity test, and at least 10 to the fourth power CFU for qualitative test of solid media of transport media. And after selectivity test, the inoculum of the non-target microorganisms should contain at least 10 to the fourth power CFU, either per plate or tube. And finally, for plate specificity says the amount of inoculum of at least 1,000 CFU. This annex, Annex E, indicates the culture conditions, control strains, and their culture collection codes, and expected reactions of the test performance. When there is more than one strain for an assay, such as, for example, here we can see Staphylococcus aureus, the minimal number of strains to be used is indicated by the letter B, which we have right here. And on the other hand, free choice strains are also indicated with the letter, for example, here E. coli D. And in this case, at least one of these two strains should be used, but that is a free choice. So in this case, the identifiers of the strains are indicated with the number of the World Data Center for Microorganisms, WDCM, which have their equivalents for other collections, such as, of course, ATCC, which is one of the most used. And in the case of Annex F, we would have the same, the performance criteria to evaluate the performance of the culture media used for water analysis. So Annex K, we will review later in the modification section of the webinar. And last but not least, in this part of quality management, we of course have the documentation of the results obtained from each performance test. All the data obtained must be properly documented as its storage is recommended in accordance with the implemented quality management system. In this case, ISO 11133 provides an example of a control card for the documentation and evaluation of the results of these tests. So in this document, we have, of course, the culture medium that we are evaluating together with all the information for its identification, manufacturer code, if applied, supplier or manufacturer, if it's supplemented, batch quantity, if it meets the physicochemical characteristics in terms of appearance, consistency, pH, filling, or thickness. So then the microbial contamination, the number of plates or tubes incubated, the conditions of said incubation, and the results obtained. And then more specifically, the performance tests that apply to each case, which would be productivity, selectivity, and specificity. The strains used, the incubation conditions, and the reference media used should be added here. The expected criteria depending on the type of the medium test and the results obtained, and if all the criteria and aspects are met, if the lot is released, and the details of conservation and storage. So in this third part of the presentation, we will review performance test types for all kinds of media: solid, liquid, diluents, transport media. These are general methods that are applicable to most culture media used in food, feed, and water analysis, but may not be suitable for some specific media. So the specific standard for the medium should be consulted. To start, we need to be clear about each criteria and when they should be used depending on the medium, which, as I have mentioned, will depend basically on the use of each culture medium. Then we have that the productivity is a criterion that we will use to verify that there is a good growth of the target strain in the culture medium. That is our microorganisms of interest, of course. Selectivity then refers to the capacity of the medium to totally or partially inhibit interfering strains, usually contaminating flora that is accompanying the sample. And the specificity is a confirmation that the interference strains that are not inhibited do not produce characteristic colonies either. In this case, we would have to take into consideration both the use of the medium, where it is for counting, dilution, or enrichment, as well as its nature, whether it's solid or liquid. For example, for a MKTTM broth used for the selective enrichment of salmonella, for which qualitative tests of productivity and selectivity would have to be carried out. And to give just another example, for a selective agar for detection such as TBX, tests would be carried out for the 3 criteria by qualitative methods. You don't have to keep this always in mind. You should not have to memorize it because the ISO 11133 itself is in charge of indicating what criteria or criteria and test method must be carried out for each medium, which we will see in some practical cases later. First, since we have already cleared the criteria and the methods, we will start with solid culture media. I'm not going to dwell on each essay because they are very specific procedures, so rather we're going to quickly review each one. So we have the quantitative and qualitative assay for solid media. In the case of quantitative methods, we have on one hand the productivity that must be reached at a defined minimum limit, and that is specified in either ISO 11133 or in the specific medium ISO, which is determined by calculating the productivity coefficient PR. On the other hand, selectivity is calculated using the selectivity factor SF and inoculating selective media, and the reference media with inoculate of non-target microorganisms. This factor must be a minimum of 2. And on the other hand, we have qualitative tests where the streaking method is used. For productivity, the target microorganism must reach a value of 2, which means good growth, while for selectivity tests, the result will depend on the degree of inhibition of each medium, but again, it must be total or partial inhibition. Then we continue with liquid media, and in this case, we have 3 types of methods. We have the quantitative method where the productivity is satisfactory if a growth of the target microorganism is observed from the dilution that provides less than 100 CFU in the non-selective agar plate. The selectivity factor is also determined, SF, based on maximum dilutions, and as in solid media, it must be a minimum of 2. Then we have 2 qualitative methods. In the first, one mixes target microorganisms, non-target microorganisms, or a mixture in the same tube. Productivity is satisfactory if good growth of the target microorganism is observed, and selectivity is satisfactory if no growth of non-target microorganisms is observed on the non-selective agar plate. And lastly, the qualitative method for confirmation test media, where if the medium is clear, growth can be observed due to turbidity, and turbid media should be so cultured to demonstrate growth. Finally, we have the diluents and transport media. The purpose of the diluent test is to verify the capacity of the medium to allow the survival of microorganisms without their growth or reduction during the contact period. For them, the colonies, or T1, of the inoculated plates must be counted after the inoculation of the diluent, which should be within a range of plus or minus 30% of the initial count, or that is T0. For transport media, the capacity of the medium to preserve the viability of the microorganisms inoculated in it during the transport period is determined, again, without there being an increase or decrease in the level of microorganisms. In liquid media, as with diluents, the number of microorganisms T1 should be in a range of 30% of the initial count, which again is T0. In solid media, the transport medium is incubated, a subculture is performed on a non-selective medium, and there should be visible growth of microorganisms after incubation. We are already coming to the almost to the practical part of the webinar. We will quickly review the modifications that have, well, the amendments that have affected ISO 11133, beginning with Amendment 1 of 2018, which did not really mean a major change in any method, but rather small substitutions, additions of certain text. Some rows of certain media in annexes E and F were modified and added. For example, there were some changes, slight changes for XLD agar and TBX agar. And although it was not a very meaningful, if you will, change in the ISO to make a new version, this shows us that the ISOs are constantly updated and new information is added, obviously in part due to the feedback and the needs of the industry. As for modification amendment 2 of 2020, in this part, in addition to small modifications in the body of the ISO, there was an important annex addition, which is Annex K, that I mentioned earlier. This annex specifies control strengths for performance assays of confirmation media and also reagents such as stains or dyes. But keep in mind that serological reagents are not included. In this case, the inoculum corresponds to the subculture of an isolated colony, so the yield test is qualitative. The specific standard for each medium or product is also indicated, since the strains indicated in each of these have not been added in the annex. So it is very important to consult them if the strain is not found. And with that, we have reached the last part of the webinar, the most practical part to corroborate all of the above in a day-to-day basis. We are now going to make a comparison with the control indicated by ISO 11133 of a specific medium. In this case, we have chosen ALOA versus what we do at Conda Lab. We are going to start with this ALOA, which is a selective medium for the detection and enumeration of Listeria monocytogenes. In this case, ISO 11133 asked us to carry out 3 tests for the performance criteria, as we can see here: productivity, selectivity, and specificity. Unfortunately, this has become obsolete and has been replaced by the specific standard of ALOA, which is indicated by the same ISO 11133, which is ISO 11290. It shows us the situation that ISO 11133 should not be compulsory followed, since later ISOs that merge become the new standard to comply with, that is specific ISOs. So therefore, in addition to consulting ISO 11133, the specific ISOs must be consulted as well. The difference we have between ISO 11133 and 11290 is basically the incubation conditions that we can see here. There is a change between 44 hours to 48 hours. So now we are going to look at our Conda certificate for this specific batch, 211231, and compare with the most up-to-date control for ALOA according to, of course, ISO 11290. The regulations indicate, again, productivity, selectivity, and specificity tests must be carried out with the new incubation conditions. We use the minimum strains marked with B and also the D strains, of which we have a choice between one or the other, and the rest of the indicated strains. And following the methods, quantitative or qualitative, we obtain the expected results. For Listeria monocytogenes, blue-green colonies with an opaque halo, and for Listeria innocua, the same but without a halo. And we have to find a total inhibition of both Enterococcus faecalis and E. coli. So that is to say, our aloe is not manufactured according to ISO 11133, which we are sometimes asked, because this regulation is not about formulation, rather than our aloe is controlled according to ISO 11133, which, as we have verified right now, it complies completely. Next, we have another example. We have GBPC agar, a selective medium for Legionella enumeration. ISO 11133 indicates the following. Tests must be carried out for productivity and selectivity criteria in these established conditions with these controlled strains. On this occasion, our reference medium will be the BCYE, not TSA. And well, we have to do it according to this type of method and expect these white, gray, blue, purple colonies. However, reviewing the specific standard indicated by, again, the ISO 11133 itself, which would be ISO 11731 of 2017, we see that we have basically the same information as in ISO 11133 with one small exception in strains. Pseudomonas aeruginosa has been eliminated from the control. So with the most up-to-date control, which would be that of 11731, we have our control as an example of batch 132287 of the GBPC ready-to-use plates. We are going to compare and verify that in our certificate, we have the two tests required according to these conditions with the indicated strains, the BCY medium as well as the reference medium. The medium is validated, since its performance is satisfactory, and the expected results are obtained. Grayish blue colonies for Legionella strains, E. coli partially inhibited, and Enterococcus totally inhibited. And then the last example that we are going to review is going to be that one of a diluent, saline peptone water. We have our certificate of analysis for batch 212272. In this case, what is indicated in ISO 11133 for the control of saline peptone water has not changed. So very lucky for us. And this shows us that ISO 11133 continues to be a very relevant international standard. So we do not have to discard it and shove it under the bed. And incubation is carried out under these conditions with E. coli and Staphylococcus aureus as control strains, and the reference medium is, yes, of course, the TSA. And again, given that we follow the test indicated for its control and the results obtained as are expected, 30% more or less than the initial count, we can conclude this batch of saline peptone water has been validated according to ISO 11133. So with this slide, we wrap up the webinar. We're going to very quickly answer some of the questions that you have submitted, because I've taken a bit more of the presentation time because the subject is quite interesting, and this ISO 11133 has a lot of information that we needed to go through. So let's go with the first question. What is the frequency of water testing outlined by the standard? So ISO 11133 doesn't indicate a frequency for water testing. It only mentions, like I said, that it should be regularly monitored. So it should be based on your own functions of the laboratory, on your own frequency. So if you, for example, are preparing every day culture media in your laboratory, well, we could recommend you a weekly testing, for example. But if on the other hand you use more ready-to-use media for which you have to do absolutely nothing, and then sometimes you, for a specific medium, you prepare it from dehydrated formulations, then maybe monthly water testing could be a good frequency. So that should be really up to you. And if you have a question, please send it through the question box, because someone uh, okay, has raised the hand, but you should send it through the box. So let's see what else I have here. Okay. When you say pH of media at 25 degrees Celsius, is this covered by a range? Um, Well, yes, we could say that. It doesn't have to be exactly 25 degrees Celsius. Of course, you can have a range of, I would say, a degree or less, maybe from 24.5 to 25.4 degrees Celsius. That would be correct. There would be no problem. Um, what tests should be carried out for media prepared from individual ingredients? Well, I didn't mention this. The ISO 11133 does mention what to do in case of a preparation from the individual ingredients, because this is something that we don't encounter as often. But you would have to do a quantitative test to detect any deviation in the quality of the individual basic material, raw materials. Also, of course, you should test the productivity of the medium, and you should keep in mind the internal production controls of the laboratory. So it is quite a challenge when you are preparing from individual ingredients. So I think that is also part of the reason why we don't see it as often. Okay. I'm gonna answer a couple of our more questions because I don't want to take more of your time. Here we have a very interesting one. It says, when is the new version of ISO 11133 expected? This year. So it is quite interesting because, of course, the last version of ISO 11133 was in 2014. So we could expect something soon, but I would not say this year. Probably it would take some time. Of course, we don't know this, but we do know that the latest periodic revision of ISO 11123 started in 2020 because of the second amendment that we have. So maybe in next year or in a couple of years, we could have a new version of the ISO 11133. We could expect it, yes. If, okay, we have, if media such as VRB has been prepared but hasn't been used up, can it be used the following day, as well as if it passes all quality control checks, or should it be discarded, considering cost factors as well? Like I said, if it's not indicated in this ISO 11133 or in the specific ISO for BRB media, you can storage it under obviously control conditions, that is refrigeration, etc. You can, if it's not indicated otherwise, that VRV has to be discarded if it's not used. If it's not indicated as that, then yes, you can use it the following day or in a short period of time. Of course, you have to do a quality check, and if it passes, there is no need to discard it. Again, you have to be very mindful of what the ISO 11133 or the specific ISO is indicating. If it says no, medium VRV has to be discarded if it's unused, then even if the quality check control passes, you should do it if you are following ISO methods. So I don't see any problem with this situation and using the media the following day. We need to adjust pH of media after sterilization. For those media that require supplements, do we take it before or after additional supplements? Okay, so I'm thinking you're referring to media that needs to be supplemented, right? The pH has to be done of the completed finalized media. So that is very important. You cannot control the pH and that it passes and then add something else. No, no, no. The pH must be measured when the media is complete, finalized. All the supplements it's added, everything. So sterilization, everything. So that's the reason it has to be when the media, pH control must be done when the media is completed, completely supplemented, finalized, and cooled to 25 degrees Celsius. So you have to do it after supplementation. And well, we have a couple more questions, but don't worry. As always, we are going to answer these via email this week and maybe next week, because we're almost at the end of the week. And we hope that this webinar has been very interesting for you. Both the recording and the certificate of participation will be, you will receive it tomorrow. And we have very interesting on the laptops planned for this year. So please don't forget to follow us on LinkedIn and subscribe to the newsletter, because we keep you informed via these two ways. So from Candelab, we will see you next time. Thank you.